So hey guys, welcome back to my channel, and my name is Wendell Reyes, and now I'm summarize the chapter 9 entitled Transport Layer. This chapter 9 have a 4 section: the 9.0, 9.1, 9.2, 9.3. Then the section 9.0 is introduction. The section 9.1 is transport layer protocols. The section 9.2 is the TCP and UDP. The section 9.3 is the summary. So let's summarize this chapter. Transportation of data. Role of the transport layer. An application generates data that is sent from an application on a source host to an application on a destination host. This is without regard to the destination host type, the type of the media over which the data must travel. This is without regard to the destination host type, the type of media over with it. The path taken by the data, the congestion on a link, or the size of the network, as shown in the figure. You must see the transport layer moves data between application or devices on the same network in the network. Transport layer responsibilities. Tracking individual conversations. A host may have a multiple applications that are communicating across the network simultaneously. Each of these applications communicates with one or more applications on one or more remote hosts. It is responsibility for the transport layer to maintain and track these multiple conversations, segmenting and resembling segments. Data must be prepared to send across the media in manageable pieces. Most networks have a limitation on the amount of the data that can be included in a single packet. Transport layer protocols have many services that segment the application data into the blocks. At the destination, the transport layer must be able to reconstruct the pieces of data into a complete data stream that is useful to the application. Identifying the applications. To pass the data streams to the proper applications, the transport layer must be identified to the target application. TCP features. TCP and UDP is important to understand how each protocol implements specific reliability features and how they track conversations. In addition to supporting the basic function of data, segmentation and reassembly, TCP as shown in the figure 1. Establishing a session ensures the application is ready to receive the data. Same order delivery ensures that the segments are reassembled into the proper order. Reliable delivery means lost segments are resent so the data is received complete. Flow control ensures that the receiver is able to process the data received. TCP is a stateful protocol. A stateful protocol is a protocol that keeps track of the state of the communication session. To track the state of a session, TCP records which information it has sent. Sequence number 32 bits. Used for data reassembly purposes. Acknowledgement number 32 bits indicates data has been received and the next byte expected from the source. Header length 4 bits, known as data offset, indicates the length of the TCP segment header. Reserve 6 bits. This field is reserved for the future. Control bit 6 bits. Include bit codes or flags which indicate the purpose and function of the TCP segment. Window size or 16 bits indicates the number of bytes that can be accepted at one time. Checksum or 16 bits used for error checking of the segment header and data. Urgent or 16 bits indicates if the data is urgent. The UDP pictures. User Data Diagram Protocol or UDP is considered a best effort transfer protocol. UDP is lightweight transport protocol that offers the same data segmentation and the assembly as TCP, but without TCP reliability and flow control. UDP is such a simple protocol that it's usually described in terms of what if it's does not to compare to TCP. Pictures of UDP. Data is constructed in the order that is received. Any segments lost are not resent. No session establishment does not inform the sender about resource availability. TCP communication process. An individual order server cannot have two services assigned to the same port number within the same transport layer services. You must see the client 1 HTTP request. Source port 49152. Destination port 80. So this is the destination port 80 HTTP and the client 2. TCP reliability. TCP segments may arrive at their destination out of order. For the original message to be understood by the recipient, the data in this segment is reassembled in the original order. The ISN does not begin at the 1, but it is effectively a random number. This is to prevent certain types of malicious attacks. The receiving TCP process places the data from a segment into a receiving buffer. Segments are placed in the proper sequence order and passed to the application layer when reassembled. Any segments that arrive with the sequence numbers that are out of the order are held for later processing. Scroll. UDP low overhead versus reliability. UDP is a simple protocol that provides the basic transport layer functions. It has much lower overhead than TCP because it is not connection oriented and does not offer the sophisticated retransmission, sequencing, and flow control mechanism that provide reliability. The low overhead of UDP makes it very desirable for protocols that make simple request and reply transactions. For example, using TCP or for DHCP would introduce unnecessary network traffic. If there is a problem with a request or a reply, the device simply sends the request again if no response is received. This is the whole summary of Chapter 9. The transport layer provides transport-related services by dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information to reassemble the segments back into application data, passing the assembled data to the correct application. The application developer decides the transport layer protocol that best meets the requirements for the application. It is important to remember that the other layers all play in the data network. Communications and influences its performances. So this is, chapter 9 is all about the TCP, the transport layer. So thank you for watching my video. That's all for chapter 9. Thank you.